How's it going, everyone? In today's video, we're going to look at monadic error handling in Python, the idea of representing failure as data instead of throwing exceptions. Now, before we do anything, I'd just like to thank Zed for sponsoring the channel this month. Zed is a lightning-fast code editor written in Rust, and I've been using it to do all my coding for months now. If you feel like trying out Zed, I've left a link in the description box down below where you can download it for free. Anyway, let's get back to the video. When you call a function that might fail, you usually get either a return value or an exception. With a monadic approach, the function always returns a value. That value is either a success with a result or a failure with an error. The type system can then reflect that explicitly. This design is inspired by Rust's result type, engineered to work within Python's OOP approach since we don't have Rust's sum types, also known as tagged enums. We use a protocol and two data classes, which would look like OK and to get the same either success or error shape. Now, why would you want that? A few reasons. First, it makes the possibility of failure visible in the type signature. Second, you can chain operations without try and except at every step. Third, it encourages handling errors when they make sense instead of letting them bubble up as surprises. This style is common in languages like Rust and Haskell. In Python, we don't have it built in, but we can build a small result type and use it consistently. But now let's define the two main shapes we care about. OK, which is the success, and which is the failure. We'll use a protocol so that type checkers and humans can see both cases. Map lets you transform the success value and leave errors unchanged. Bind runs a function that itself returns a result, so you can chain failable operations. Unwrap OR gives you the value or a default if it's an error. So first let's import the data class, and then let's import the callable type and the protocol type. And the first thing we're going to do here is create a class called result. And this is the protocol for the result monad, which will either end up being OK or an error. And as I mentioned earlier, map will let us transform the success value and leave errors unchanged. Bind runs a function that itself returns a result, so you can chain failable operations. And unwrap OR gives you the value or a default if it's an error. We use a protocol because we want to encapsulate the shape of the two classes, while not making them a part of the same family of classes, to make sure they can never be interpreted as the same type, while allowing us to properly type check the code. Now below, we're going to create a data class, which is the success case, and this holds the successful value. Here, we store both the success value and the error type as type parameters, as OK can fail with a fallable function call. We default to string, because most functions that can fail will return a string error message. So inside here, we want to create a value of type t, which will be our success value. Then we're going to want to create a function that maps this. And this will transform the success value. Since we are OK, we will apply f, which is a callable, and stay OK. So here we can return OK with the function applied to self.value. Next, we have a function called bind, which will run a fallable function on the value. So once again, here we run a fallable function on the value. We're OK, so we just call f. And then below, we have unwrap OR. Here we have a value, so we return it and ignore the default. Next, we're going to create a data class, which holds the error. Here, we only store the error type as a type parameter, as can only fail with a static error object. This is because we can never return OK from as is a terminal state. So inside here, we need to create an error of type E. And this is our error value. It can be any type, as it is not used in the map, bind, or unwrap OR methods. And instead, we allow the user to handle the error however they wish. So once again, we will create the map, which just returns self since we are an error. We will create the bind function. And since we are an error, bind leaves us unchanged, and we don't run the function. So here we just return self. And finally, we create the unwrap OR function. And since we don't have a value, we just return the default. This provides a basic railroad-oriented pipeline for error handling in a form that integrates well with Python. by making the error class a subclass of the exception class, we can raise it as an exception at the end of the pipeline if we are in an error state. Now that we have this result type, which you can place in a different module, we're going to use it in practice. For this example, I'm just going to write everything in the exact same script so we don't have to import them. And we'll start with some simple examples. A function that returns OK or error. Then we'll use map to transform success values, bind to chain followable steps, and unwrap OR to get a value or a default. After that, we'll build a small pipeline in what people call railway-oriented style. The idea is that you have a pipeline of steps. Each step returns a result. If any step returns an error, the rest of the pipeline is skipped and you get that error. If every step returns OK, you get the final value. So the track either stays on the success rail or switches to the error rail once, and then stays there. So let's implement a minimal config parsing pipeline and wire it all up in main. So here we have a function called parseInt, which takes a string and returns a result. And what we're going to do is try to parse that int. Otherwise, accept the value error and return an error. And we will print that it is not an integer. And these functions don't really matter. They are just here to demonstrate the result type in action. Below, we can create our main entry point along with our if name is equal to main check and test it out. Here we can debug and print parseInt with the value of 42 as a string. When we run this, we should get a response that says OK along with the value. If we try to pass a value that doesn't make sense, such as hello, we're going to get the error back. Next, we can use map to transform a success value. So here we're passing the value of 42, and what we're going to do is map it to lambda times 2. So when we run this, what we should get as a value is 84. And just like that, we were able to use that result. Now, before we move on to the next example, let's create one more function, which is called ensure positive, which takes a number of type integer. And this returns another result, which either contains an integer or a string. And here we're going to check if the number is less than 0, then it is a negative number. So we will return an error. Otherwise, we will return OK with the value. So with that, we can go back down to main and continue with the second step in the process. So here we'll use bind to chain another followable step. If the first step fails, we never call the second. So what I'm going to do here is create R2, which will try to pass the integer and bind it to ensure positive. If that works, it's going to print R2, which contains the value of 42. Otherwise, if we try to use it with a negative number, it's going to return an error and state that the number must be positive. And finally, just like in Rust, we have unwrap OR, which gives us a value or a default. And this is handy at the end of the pipeline when you're okay with a fallback. So in this example, we're going to try to grab a value from our parseInt function, and here we're going to use unwrap OR, and the default will be set to 0. So with that being done, we can print unwrap OR and the value. And as a result, we should end up with 0, since x is not a valid value. But if we were to insert something such as 100, it should work just fine. We get the value that we're expecting. Anyway, let's get rid of all of this because next we're going to create a function that passes a config line. And for that, we do not need any of these functions. We're going to type in def parse config line, and that will take a line of type string. So what this will expect is a string such as this one that contains a key and a number. What it's going to do is split and pass. Any failure will become an error. So first we'll have a line, which will equal line.strip. And if the colon is not in the line, we're going to return an error. Next, we're going to partition the key, the separator, and the rest. So that's going to separate the key, the colon, and the value into 3 parts. Then right below, we're just checking whether it has a key. Otherwise, we return an error that says that the key must be non-empty. Then we can try to grab the value, which should be of type integer. And if that fails, we will raise a value error. Or we will accept a value error, because what we will really be doing is returning an error, which says that the value must be an integer. But we got this instead. And if everything works fine, we're just going to return the OK type with the key and the value. And before we use this, we have one more function that we should create, and this is a validate port function. For this to work, we will need a key and a value pair, and we're going to destructure that from the pair we provide. Now, if the key is not equal to port, then we will return an error, which states that it's an unknown key. Also, if the value is not between 1 and 65,535, we will also return an error that the port must be in that range, but we got this other value. Otherwise, we will be impressed that someone did something right, and we will return OK with the pair. And with all that being done, we can go to our main function and create a string, which will contain a port with the port number being 8080. Next, we can create a result, which will try to parse that string, and it's going to bind the value to validate port to make sure that it's correct. And considering that we provided a valid port, printing this result should give us the OK type back with the value. Now, what happens if we provide an invalid line? Well, I'm glad you asked. If we type in port and not a number, or to be fair, we could even do nan. If we try to print this, what we will get back is the error that the value must be an integer, but we got nan instead. So that was an invalid line. Next, let's use a line that passes but fails validation. So the pass will succeed, but validate port will return an error. As you can see, the port must be in that range, but we got this huge number instead. And once again, at the end, we can use unwrap or to extract the value, or provide a default, such as port and 80. Right now, if we were to print final, we would end up with port and 80 because the string we used was not valid. If we provide a valid string, such as 8080, it will use that value instead. Otherwise, if there's a typo or something random there, such as sport, it's going to fall back on the default value we provided right here, because unwrap or relies on the OK value to be able to use it. Otherwise, if it's an error, it just returns the default, which is an incredibly safe way of handling errors. And what's really nice about this is that we don't need to disrupt the flow in our program. Everything's being handled through the OK type and the error type, via the result type. Anyway, that's really all I wanted to cover in today's video. Do let me know in the comment section down below what you think about all this, and whether you have any other questions regarding monadic error handling in Python. But otherwise, as always, thanks for watching, and I'll see you in the next video.